Good morning, soldiers. Guess what? Drill Sergeant Reid is back. It's time for you to get out of bed, soldier. Rise and shine. Get your shoes shine. Get in line. 10 hunt and suck in that gut, soldier. Today it's EOG Boot Camp Day number 7. And today's topics are surface area and volume. So we're going to be talking about how to cover those things and how much those things will hold. So time to get ready. Get your packet out. Get it turned to the surface area and volume page. Now let's get down to business. It's time to get into some surface area and volume with Drill Sergeant Reid. Here we go. Alright, so as we look at our packet here today, the first thing I want to remind you about on surface area are the surface area words. Alright, so the words are the vocabulary. So if you read a word problem, okay, these are the words that if you see it in the problem, you might think about, oh, this is a surface area problem. That would be, you're going to cover it with something. Alright, you're going to cover the outside of it. Maybe you're going to wrap it with wrapping paper. Okay, if the problem says something about wrapping paper, maybe you're going to give old Drill Sergeant Reid a gift. Ha! Might want to wrap it with some wrapping paper. If you do, make sure it's brown, green, and black. Give me some camouflage wrapping paper. Alright, you might paint it. Maybe you're going to give it that nice camo paint job like I see some of them trucks out there driving around Redneck Thomasville in. Maybe you're going to make a box. Put that gift in. Alright, go make a box. So if you make a cardboard box, that would be surface area. Maybe you're going to put some icing on a cake. Hey, going to give old Drill Sergeant Reid a birthday cake. So if you ice the cake, okay, that would be around the outside of it. That's surface area. And the last thing I want to remind you of is that surface area is all in square units. Okay, what do I mean by square units? Alright, that means something like inches squared, feet squared, centimeters squared, meters squared. Everything is to the second power because we're going to be finding area of this stuff, right? We're going to be finding area. So there's 4 things that we got to do, and I'm just going to review them real fast. So let's we'll break this into 4 little boxes here, and we're going to do a cube here first, and then we're going to do rectangular prism over here. Alright, so for the cube and the rectangular prism, alright, they actually have formulas that you can use. Okay, so they actually have formulas. So the cube's formula is 6 faces, and then you must find the area on one side by doing s squared. Okay, so 6s squared. For the rectangular prism, it's the little bit longer one. Okay, there's 2 of each face, so you got to do 2 length widths plus 2 length heights plus 2 width heights. Alright, so those are the little formulas you'd want to use for cube and rectangular prism. So real quick, I'm just going to draw a cube in here. Alright, so we've got our cube, and let's say we're going to cover it, or we're going to wrap it with wrapping paper, and on this side it is 8 centimeters long. Alright, so if it's 8 centimeters there, and it's a cube, of course, that means it's made up of squares. It's 8 centimeters there. Alright, so all we got to do is 6 times 8 times 8, because our formula is 6s squared, so we got to do 8 times 8. And of course, 8 times 8 is 64. So that means the area of one of those faces is 64. You just multiply that by 6 because all the faces are the same. So let's get our old trusty calculator out here. Let's get old blue out. And if we do 8 times 64, can y'all see that? 8 times 64, 6 times 64. That means our surface area for that cube, if you wrapped it or you iced it or whatever, would be 384 centimeters squared. That would be the total surface area, 384 centimeters squared. Alright, let's hustle on down here to a rectangular prism. Of course, a rectangular prism is going to look like a cereal box because it's got rectangles in it, so it's going to look something like that. Okay. If you want to give it the 3D effect, of course, you can put your little dotted lines in there, whatever makes you happy. Alright, so again, there's 2 of that side, there's 2 of that side, there's 2 of that side. Again, it's got 6 faces, so you got to cover all those faces, wrap them with wrapping paper, paint it, whatever. So let's say here we know this was 10 inches. Over here on the side was 3 inches, and then it's 15 inches tall. Okay, so that would be the length, width, and height. So length, width, and height. Okay. So you got to do 2 of the length width sides. I'm going to come down here and write that. So 2 of the length width sides would be 2 times 10 times 3. Plus we got to do 2 of the length height sides. So that's 2 times 10 times 15. And then 2 of the width height sides over here would be 2 times 3 times 15. All right, we're going to have to add all those faces together. So of course that's 30, and 2 times 30 is 60, and that's 150, and 150 times 2 is 300, and that's 45, and 45 times 2 is 90. So when we add all that up, that's 390 plus 60, so that'd be 450 inches squared. Again, remember, everything in surface area is in square units, right? Everything is in square units. All right, then we get to the old triangular prism. Now, there really is no formula for this, but they're going to look something like this. You'll have a triangular end, and it'll kind of be shooting off over there to that end. And again, you can dot your stuff in if you want to. All right, so a triangular prism has 5 faces, okay? It's got the 2 triangular ends and 3 rectangles, okay? So we got to do 2 triangles plus the 3 rectangles. So you're going to see this little dotted line dropping down in here, and it's going to have a little right angle on it, okay? Probably going to have that, have a little line pointing to that. And let's say that that is 8 centimeters. And down here, let's say this is 10 centimeters. Let's say this whole thing here is 25 centimeters. And then over here, let's say this is, if that's 8, 10, let's do 14 there. All right. So we got to find the area of the 2 triangles. Well, those little numbers that touch that right angle are super important. Okay, so the height of the triangle is 8, and the base of the triangle is 10. So we got to do, if I break this into my little T chart here, okay, do the triangles and rectangles. So I got to do 8 times 10 divided by 2. And of course, that's 80 divided by 2, which is 40. But that means that one on that end's 40, and that one on that end's 40. So I'm going to write down 40 twice. Or, of course, if you're a super smart person, you can just say, well, 8 times 10 will cover both of them, and 8 times 10 is 80. But that means that triangle's 40, and that triangle's 40. All right, the hard part's the rectangles. Last time I did this, we kind of traced around them with some different colors, but for time's sake, I'm just going to go through it, and then I'm not going to trace them in the color today. So right here on this side, you can see this rectangle, as I go by, that says 25 and 14. 25 and 14. So I got to do that one. I'll do that on the calculator in just a second. Then this one down here on the bottom, if I do it, okay, this one is 10 by 25, so that's 25 times 10. Now the only question I've got is, what about this one back here on the back side? Well, this is a isosceles triangle, so that side and that side are the same. So I got another one back there that is 25 times 14. Okay, so I could say that that little piece back there is also 14. So 25 times 14, I got 2 of them. All right, so let's do that real fast. 25 times 14, 50.
And of course 25 times 10 is 250. And 25 times 14 again would be 350. Alright, now I'm just going to add all that up. I got a couple 350s, I got a 250, and then I got a 40 and 40. I'm just going to go ahead and add 80 to that. So my grand total would be, if I add all that up, 680 centimeters squared. That would be my grand total surface area. I added all that and all that. Okay, added up all 5 faces. Woohoo! All right, we're doing good so far. So we got one more to do, and that would be the old pyramid. All right, so I'm going to draw a little pyramid here. Of course, you can think these are about sitting out in Egypt or whatever. So we've got the pyramid here. Again, if you want to dot your stuff in so it looks 3D, feel free to do that. Okay, so on this one, let's say it's got a square base. Okay, so down here, let's say this is 28 yards. So if it's 28 yards over here and it's got a square base, of course that means it's going to be 28 yards over here. Then you'll have this little thing coming down on the side to give you the slant height. Again, it'll give you the little angle on the little right angle on there. Might have a little arrow drawn into that. All right, let's say it's 38 yards on the slant height, okay, on the triangles. All right, so for a pyramid, you've got to find the area of the square base. So we've got to find the area of the square base plus we got to find the area of the 4 triangular sides, because again it's got 5 faces. Alright, so let's make us a little T-chart here. Add these up. Alright, so easy enough. The square base, of course, you're just finding the area of a square, which is side times side, okay? Or 28 times 28, or you can write 28 squared, of course, if you want to do that. Remember, the term squared comes from getting the area of a square. I'm just going to go ahead and do 28 times 28 there on my calculator, and that is 784. Hopefully you can see that. So the area of the square is 784. Alright, all 4 triangles that are going around, of course, they're exactly the same. So let's see, if we do, that would be base times height. So that's 28. 28 times 38.
Divided by 2. 28's the base, 38's the height. And of course, since it's a triangle, you got to divide it by 2. So let's do that here. 28 times 38 is 1,064. And then I'm going to divide that by 2, which would be 532. And there are 4 of those, because all 4 triangles are the same. So I'm just going to go ahead and multiply that by 4. And that would be 2,128. Okay, so now I know my 4 triangles. 4 of them are 532 each, and that was 2,128. I'm just going to add these 2 numbers together right here. My square base plus my triangles, so 2,128 plus 784 gives me a grand total of 2,912. Okay, so the surface area for this is 2,912 yards squared. Alright, so that's a little review of all the surface area stuff. Okay, surface area there. Down here on the volume, I'm just going to run through the volume words, and here we go. So the volume words would be fill, hold, contain, capacity, and remember stuff like that where you're filling it up with something on the inside, and all that stuff is in cubic units. Cubic units. So that means like centimeters cubed, inches cubed, feet cubed, so forth and so on. That's what cubic units mean. Alright, so these are the basic volume formula is a big old capital B times H. And what that means is you can find the area of the base, that's base area, times the height. So if you can find the area of the base, and then multiply that by the height of the whole thing, you can find the volume for anything. And they're pretty simple. Okay, this is a little easier than surface area in my opinion. So let's go through, and we've got some formulas we can write down for all 4 of them. Cube, rectangular prism, triangular prism, and then the pyramid. Okay, so cube, real simple. Side times side times side. Okay, if you want to find the volume of a cube, you just do side times side times side, or s to the 3rd power. That's where the term cubed comes from. Okay, from getting the volume of a cube. Rectangular prism, I'm not going to waste your time a whole lot on that. That's length times width times height. Again, if you find the area of the base, you do length times width, then you multiply it by the height, you got that one. Okay, you can't get any easier than cube and rectangular prism. Triangular prism, now probably the simplest formula, of course, is to do length times width times height, and then you're going to divide it by 2, because a triangular prism is half of a rectangular prism. Or the other one you would probably see would be base times height divided by 2 times the height of the whole thing. Okay, and we'll take a look at one of those in just a second. And then the pyramid, if you remember, we did a little water pouring experiment on that, and we did it with the square base. So it's side times side times side divided by 3, because it took us 3 pours of the pyramid to fill up the cube. Or you could write it like this, s to the 3rd power divided by 3. So here to finish up the video, folks, we're going to do one of these each on the triangular prism and the pyramid. Okay, so triangular prism here, and let's start with that one. So I'm going to go back up here and draw another triangular prism similar to what I did on the one up there. Let's draw a little bit smaller. So let's say again we've got our little line drop down through here, and we know we're going to use those same numbers. Alright, so we've got 8 here, 8 centimeters there, 10 centimeters there, and then 25 is my number over here. And that's really all you need, okay, because you got to find the area of the base, and once you do that, you multiply it by the height. Okay, so area of the base, multiply it by the height, and then
you know, you're good. So the formula, of course, I'd want to use would be this. So I'm going to do this one right here. I'm going to do length times width times height divided by 2. So there's my length, there's my width, there's my height. I'm just going to do that one. So 25 times 10 times 8. And I'm going to divide that by 2 because a triangle is half of a rectangle. So I'm going to put it in right here. 25 times 10, of course, is 250. 250 times 8 is 2,000. But then I've got to remember that since this is a triangular prism, I got to divide that by 2. And I'm pretty sure that if you know that 2,000 divided by 2 is 1,000, that'd be 1,000 centimeters cubed. Hopefully you can see that. All right, final one, and we're ready to rock and roll. Let's do the pyramid. Again, on this one, you got to divide it by 3. Okay, don't forget pyramids, you got to divide by 3. All right, so we'll take our same little drawing we had from up there. Put our same numbers on here. So let's say that's 28. That's 28. And then 38 was what we had here. Alright, so for that, I guess I could change that to height right there. I could change that to an H. So side times height divided by 3. Alright, so side times height divided by 3. So side would be 28 times 28. That'll give me the area of the base. Okay, that'll give me the area of the square down there. Multiply it by the height of the whole thing, which is 38. And then don't forget on the pyramids, you got to divide by 3. So let's put them in there. Here we go. 28 times 38 gives you a big old 29,792. I'm going to divide that by 3. And that means I'm going to go to the nearest hundredths place. The volume of this would be 9,930.67 yards cubed.
Watching the enemy's getting closer.
And we're getting ready to annihilate that enemy. We're going to wipe them out. Okay? Come here in just a few days, we're going to wipe it out. So keep on working hard. Keep that gut sucked in. Keep your head down. And keep on marching up that rankings ladder. Until next time, soldier, this is Drill Sergeant Reid saying, you are dismissed!